Hi everyone. Today we're going to explore states of matter and we're going to look at solids in particular. Do you remember in the story of the creation of the universe? Do you remember that story? All the little particles were given rules to follow or laws to follow. One of the laws was that with heat, particles would spread out and they would rise. And the other law was if they got cold, they would come together and they would sink. Now, Travis is going to help us and we're going to see if that is true. When we work with fire, we have to be very careful. Can you see how liquidy it's getting? The particles are spreading out. Now let's see what happens when we pour that melted wax into the bowl. Look at that. When you get cold, you become solid again. Look at that, it's become solid again. Would you like to hold on to that? Now look at this rock. The particles of solids cling very tightly together so they can make a shape of their own. Can you break that with your hand? No. What about if we try and pull on this screw? Still can't break that.
Go try and snap it. Nope.
Even by pulling on this rod won't break it.
Nope.
No. And look at this paper. If we pull on it, it doesn't break. If we do this, it doesn't break. Do you want to see if you can get that into two pieces? Huh! The paper tore, but look, there's still two solid pieces.
Okay.
The particles of this one are clinging together and the particles of this one are clinging together. But I know what you're thinking. If we could hammer the rock, then let's see. We want to protect our table. Where's our rock?
Whack.
Put it inside. Oh, this is a very heavy hammer. Let's see if we can smash the rock and see what happens.
That's the
The
one.
rock is here.
Okay. These are not working as intended. These are not working as intended. I did go for second.
Let's see.
Oh, not. I didn't try to. It was the little shots. But. Oh, it just
Wow, look at this.
It still has its shape.
Every piece
Oh my gosh,
is
that's
still a solid. It still has its own shape. Even though the pieces are separate, they still have their own shape. We're going to look at another state of matter now. We are going to look at liquids. Let me set up the experiments and you can see. We're going to look at liquids now. Liquids are not the same as solids. Travis is a solid. This chair is a solid. This table is a solid. But liquid isn't. Can you put your hand in there? Can you put your hand in the table?
Ow.
No, liquids are different. Liquids are accommodating. They allow our hands to move past or through
Oh my
it.
gosh, that was so odd.
Do you remember liquids were told to be flexible? They or their particles just roll over each other, allowing things to pass through. Do you like to see if the liquids can roll over each other?
Can I say?
Are these containers all the same?
No, some are thicker, some are taller, some are smaller.
So
Some have wider heads, like this one.
So they're all the different shape and size. Now remember that liquids or liquid particles cling quite loosely together, so they can be quite flexible. Look here. Liquids take the shape of their container. This one. Liquids don't have their own shape. They take the shape of the container they're in or whatever is keeping them in place. Solids have their own shape, but liquids don't. Let's look at this experiment. Will you pull the tape off that side? Can you see the water is pressing out sideways and downwards? What about this solid? If we put our hands on the side, does it feel like it's pushing your hands? No, it doesn't feel like it's pushing sideways. I'm going to put this heavy rock on your hands. Tell me, is it pushing your hands downwards? Yes, solids push downwards. Oh, let's put our hands on top and see if it's pushing upwards. No, solids don't push upwards. They only push downwards. What way do liquids push?
Side and down.
Liquids push side and down. What about gases? We've spoken about liquids and solids, but what about gases? Remember, their particles could travel any which way. They could go up, they could go down, they could go sideways, because they are so loosely grouped. I'm going to spray something and let's see if Travis can smell it or see it.
I could see it. And I can smell it.
And that's because gases can travel any way. If you weren't on the other side of the computer and you were in the class with me, I bet you'd be able to smell it as well. And you could smell it from quite a distance. Thanks for listening. Have a wonderful day, and I'll see you again.